In 3.6, the objective is to be able to solve problems containing perpendicular lines. We will use perpendicular lines to find the distance between a point and a line and between two lines. Let's review what perpendicular lines means. Perpendicular lines are lines that intersect at a right angle or a 90-degree angle. So remember what they can look like is like this. Here are a pair of perpendicular lines. The distance from a point to a line. Well, what does that look like? If I have a line and I draw a point, and I want to say go from this point to this line the shortest way possible. So does that mean that we're just going to go like this at any angle that we want to? Well, that's a long trip. The shortest trip is straight there. Now, what do we mean by straight there? We mean at a right angle, so a perpendicular. The distance from a point to a line is the length of the perpendicular, remember that symbol means perpendicular, segment connecting the point and the line. So again, in my picture, from the point to the line, I drew a segment that is perpendicular to the line. It is the length of that segment that is the distance. So perpendicular, remember the symbol for perpendicular, the distance from a point to a line, we draw that perpendicular. Before we look on to the examples, let's talk about when in life do we see or use perpendicular lines. On your note sheet, write an example of when you would see or use perpendicular lines outside of the classroom. Think about if you're traveling from a point to a line. You have to go straight there at a right angle. Can you think of a scenario that uses that? So now let's take a look at some examples. 1. Find the distance between the point and the line. So first of all, remember we think the distance between a point and the line, we want to think perpendicular. So if I'm in a coordinate plane, I have to remember about slopes of perpendicular lines. So I remember perpendicular, the slopes are opposite reciprocals. Opposite reciprocal slopes make perpendicular lines. So that means that first I need to calculate the slope of the line that's given. So let's find a couple points that are close together on this line. Here's a point and here's a point. I'm going to count the rise over the run. 1, 2, up, and 1 over. So the slope of this line is 2 over 1, or more simplified as 2. Perpendicular slope, the line that's perpendicular, will have a slope that's the opposite reciprocal. So reciprocal to 2 over 1 is 1 over 2. Opposite to positive is negative. So I'm going to count a slope of -1/2 from this point. So I'm going to go to this point and I'm going to say, okay, I need to do down 1 and over 2. -1 and run is 2. Put a point there. Now remember that I need to show the distance between the point and the line, so I need to connect the point to the line, and this is going the opposite direction. So let's take our slope the other way. Start with 2 to the left and up 1. 2 to the left and up 1. And now I've connected with points from that point to the line. Let's actually draw that connection. So I'm going to show that segment. I want the length of that segment. The distance, remember we think length. So I made the perpendicular segment that's perpendicular to the line. Now I need to find the length of that segment. So to find the length, I can think of square root of how much I go up and down, and how much I go over. So now I'm going to count in my graph how much I go from one point, 2 units, and to the other point, 4 units. So 2 squared plus 4 squared. So let's calculate that. 2 squared and 4 squared. 4 plus 16, that makes square root of 20. Now the directions aren't specifying how to leave my answer, so let's practice leaving it both ways. Square root of 20 is the same as square root of 4 times 5, and that makes 2 square roots of 5. If I type it in my calculator, I get approximately 4.47. So I'm going to give both answers. Number 2. Find the distance between the two lines. So again, the distance between the two lines has to be from a point straight to the other line, or perpendicular to the other line. So let's start by finding a point on one of the lines. Now notice these lines look parallel. I wonder if they really are. If I say the distance between the two lines, they should be parallel, because then it's going to be always the same distance between the lines. Let's go ahead and find a point somewhere on this line. I want to find the distance from this point to the other line. Remember how we did that in number 1? We had to think of slope. Perpendicular lines, the slopes are opposite reciprocals. So I'm going to have to calculate the slope of this line. Let's pick 2 points to do that. Let's see. It looks like it crosses through here and it crosses through here. So I'm going to calculate -1, 1, 2, 3 over 3. So the slope is -1 over 3. Perpendicular to that, the slope will be reciprocal, makes 3 over 1, negative turns into positive. So that's just 3. So I can count from this point to get to this line using a slope of 3. So let's do that. 3 is like 3 over 1. So from here I'm going to count up 1, 2, 3, 1, 2, 3, and over 1. That lands here. But I need to go towards the line. So let's count that backwards. Instead of up 3 and over 1, let's go down 3 and left 1. Or I can simply connect the points, but it's better if I have that other point. So I'm going to connect that segment that joins the two lines. There it is. Notice how it's a right angle right here. So this is the perpendicular. This is the segment that I need to calculate the length. So again, for distance, we think length. The length is the square root, and let me count how many blocks we have to travel from one end to the other. Looks like 1, 2, 3 over 1. So that's 3 squared plus 1 squared. 3 squared makes 9, 1 squared makes 1. That makes square root of 10. Now that one doesn't break down, so I'm going to either give my answer as square root of 10 or type it in my calculator, and I get approximately 3.16. Great. Let's review while we're here, constructing a line perpendicular to a given line through a point not on the line. We did this back in the previous unit, but now that we're dealing with perpendiculars, this will be a good review. So I have my compass and my straight edge, and we begin with a point R and a line. The point is not on the line. Sorry, I was a bit distracted. Begin with line K and point R. Notice point R not on the line. First, we have to section off a segment of the line. So we put our compass on point R, and then we're able to draw arc through each 2 parts of the line, here and here. That's the first thing. Notice it says, place the compass on point R. That is where we start. If it says go through a point, we start the compass here. And then we can draw those two arcs. And now we've created a segment where those two arcs intersect. Remember my suggestion from when we did this before, scribble out the rest of the line so it's not distracting you, and use that segment. From this point, it's just like bisecting a segment. So now I want you to make yourself a note that from here we have a segment from this point to this point. So I want you to think of how to bisect a segment. Think of how to bisect a segment. That's what you're doing. So what are the steps for bisecting a segment? Here are the two steps in the two different pictures. We're getting our compass over to each endpoint. So our compass goes here and our compass goes here, and that's where we draw those two little arcs that meet each other. Notice the directions specifically say, without changing the compass radius, you place the compass on the other point. Don't change the size of the opening of the compass like this. Once you have those two little marks down there, now you can make that connection and that line will be perpendicular. Finally, if you want more help on a step-by-step instruction that can actually walk you through it as you work, go to this website, themathopenreference.com, to find constructions on creating the perpendicular through a point not on the line. See you.